Hello, beta. Good afternoon, everyone. So let us go ahead and take ISI PEA 2006, question number 7 to question number 9 today. Look into the question. It says you are given, you need to go ahead and integrate this function, and the function given to you is 0 to infinity, x to the power n, e to the power minus x dx, and n is some positive integer, right? So what you can go ahead and see is simply that this is the formula for the gamma function, right? So this is nothing but this is writing this as n plus 1 gamma, right? And this is nothing but this is n factorial, right? And now what we can go ahead and do is, if I just want to write similar thing for n minus 1, what can I do? I can replace this with n minus 1. Instead of n, I can just go ahead and write n minus 1 there. And my exponent function will be as it is, right? So here, I can just write n minus 1 here, and I will just go ahead and perform the usual integration. And we know that this is the gamma function for n, and n is nothing but n minus 1 factorial. Now, if you really think about it, then n factorial can be written as n into n minus 1 factorial, right? Isn't it? N factorial can be written as n into n minus 1 factorial. And n minus 1 factorial is nothing but I n minus 1, right? So this is what I have gone ahead and done here. So n minus 1 factorial, and n minus 1 factorial is I n minus 1. So this goes ahead and becomes In is equal to n into n minus 1 factorial. So n into I n minus 1. So that will be the answer to this question. Come to the next one. It says you are given that x cube is equal to 1, then this is equal to. So if you notice in the options given to you, you will realize that all of these options actually go ahead and have a common factor out, which means somehow, first of all, I need to go ahead and bring this factor within these determinant, right? And then I need to take that factor common out. So the factor that I have to consider is cx square plus bx plus a, right? So what we can go ahead and do in this case is, because I need to make this common factor, so what I have done is, with b, you can see that there is x involved, right? So I am going ahead and multiplying column 2 with x, and with c, there is x square involved. So I am multiplying column 3 with x square, right? And because I'm multiplying one column with x and other column with x square, I must go ahead and also divide it, right? So outside, I've just gone ahead and divided it with 1 by x and 1 by x square, right? So this is what I've gone ahead and I have done here. I've multiplied this column with x, this column with x square, and outside I've got 1 by x cube. Now, if you really go ahead and realize this, if you really think about it, then 1 by x cube, we know that x cube is simply 1. X cube is simply 1. So this is going to go ahead and give me 1 by 1, which means I will be getting 1 only, right? Isn't it? So therefore, what happens in this case, that this x cube is going to be 1. And since this x cube will be 1, here I will be getting 1. And this will be eliminated. So ultimately, I can just think that this is gone and I still have this only with me, right? So this is just, I'm able to do it in this case because they have given me that x cube is 1. Okay. Now what you can go ahead and do is you can apply some kind of column transformation. So the column transformation that I have gone ahead and I have applied is that because I need this term beta, I need a plus bx plus cx square. So what I have gone ahead and I have done is, I am saying that this c1 that I have here, this becomes c1 plus c2 plus c3. Right? So the first column that I have here, so instead of a, I will write a plus bx plus cx square. Instead of b, I will write b plus cx plus ax square. Instead of c, I will write c plus ax plus bx square. Right? Column 2 and 3 intact, so 2 is as is and 3 is also as is. Right? Now, notice that I need to somehow go ahead and I need to remove these x's. I no more need these x's. the term that I required is very well there with me, right? So I don't need these x's in the second and the third column. So what I can go ahead and therefore do in this case is take out this x from here and x square from here. I can just take these x and x square out from column number 2 and column number 3. And when I go ahead and I take that out, so in the column 2, I will be left up with B, C, and A. I've taken x out. And in column 3, I will be left up with C, A, and B. I've taken x square out. So I am now getting here x into x square, which means I'm getting x cube again. And x cube is simply 1. So again, this is simply 1 and eliminated. Okay. Now I want to go ahead and I want to make sure that I am able to bring cx square plus bx plus a common, and I have to take that out of this determinant. In order to take that common, please notice that somehow I need to make this into cx square plus bx plus a. Somehow I need to convert this into cx square plus bx plus a. So if you notice here, because this is what I need common. I need common cx square plus bx plus a. So somehow I need to take that common. So what I can go ahead and do therefore is that in this equation, I can go ahead and take x square common. And when I will take x square common, I will be getting a here, right? And I will be getting c here. And I will be c by x here. And I will be getting b by x square here. But that is not what I require, right? I need a without the coefficient term, definitely. But at the same time, I also need to ensure that I get cx square. So how is that possible? This is what I need to go ahead and think. So what I have done, therefore, in this case is that I have tried to go ahead and I have tried to transform this in this way that so I have this term ax square. So I need to make ax square as a plus b. I need to make b as bx plus cx. I need to make c as cx square, right? So what I will do in this case, I will multiply throughout with x. I will multiply throughout with x, right? But if I am multiplying this throughout by x, shouldn't I also be dividing it by x so that this term remains unchanged? I should be doing that. So what I have done is I have multiplied this throughout by x, but also I have divided it throughout by x. So this gives me ax cube plus bx plus cx square by x, right? Now I have got this term. I wanted bx. I have got this term. I wanted cx square. And I have got, instead of a, I have got ax cube. But x cube is 1. So x cube just becomes 1. Right? So this term, by multiplying and dividing by x, can be rewritten as the term that I have just written below, which is going to be a plus bx plus cx square by x. Right? So this term has become this. Am I clear with that? Okay. Now let's look into the third term. So let us look into this term now. This term, a plus c plus ax plus bx square. Will you be able to do it yourself? Can you give this a try? Take a moment, try to do this yourself. So you have c plus ax plus bx square, and I need cx square. So I need to multiply this term with x square. And if I'm multiplying with x square, I need to multiply it with x square throughout. Right? So this will give me cx square, and because I'm multiplying it, I should also be dividing by x square. So I've also divided it by x square. Whenever you will multiply, whenever, you also need to make sure that you divide by that number also. Multiplication and division should go hand in hand. So I've also divided it by x square. So this gives me cx square plus ax cube plus b. This is x to the power 4. So it can be written as x cube into x by x square. X cube is 1. So this is eliminated. X cube is 1. So this is also eliminated. So I will go ahead and get cx square plus a plus bx, exactly what I required, divided by x square. So this term can be rewritten like this. Am I clear with this, beta? Now notice that I have been able to get exactly the term which was required in the answer. I somehow wanted cx square plus bx plus a. So I can see that each of these have cx square plus bx plus a. And I can take it out from this column. So now this column will become 1 by x square, b, c, a, and c, a, and b. Okay. Now let's see if we have reached somewhere with this analysis. So now you see that nothing is in 1 by something. It is either in x or x square or x cube and so on and so forth, right? So I again have to go ahead and again have to do some kind of thing in order to solve this. So I've just taken one last step. So we know that x cube is equal to 1, right? So instead of 1 here, can I write x cube? And instead of 1 here, can I write x cube? Because x cube and 1 are the same thing only, right? So if x cube can be replaced by 1, then 1 can also be replaced with x cube now. So this is what I have gone ahead and done here. So I have written x cube here also. Right? So this will give me x cube by x and x cube by x squared. So this will be x square and x. And this is exactly the form that we required in the answer. You can just verify the answer. Okay. Now let's go to the next question. So I think this was question number 8. Yeah. Let's go to question number 9. So this says a very easy question. In such cases, now it's easy to take some number and try. So it says I is equal to m square plus n square, and m and n are any two odd integer, any two. It is not saying that they are different. It says any two odd integer. I can at any point of time take m also 1 and n also 1, and that will be fine. These are any two odd integers. They haven't said that they have to be any two distinct odd integer. Distinct word has not been used. So beta I will become 1 square plus 1 square, which is going to be 2. So the first option goes ahead and says it is never divisible by 2, which is incorrect, right? 2 is divisible by 2, right? Now if I would have taken m to be just some odd integer like 3, so just from 3 I know 3 square is 9, right? And 9 plus 1 is 10. Even 10 is divisible by 2, right? So this is another property that we can see from here. You can take any odd integer, like, right? You can take any two odd integer. When you will sum the square of the odd integer, you will always get an even number. Always. You will always get an even number. Am I clear with that? Okay. Now let's go ahead and check the divisibility by 4. So in order to check the divisibility by 4, we need to go ahead and understand that it is given to me that m is an odd number. Any odd number is even plus 1. So m can be written in the form of 2k plus 1. N is also an odd number. Any odd number can be written in the form of even plus 1. So if I were to find out m square plus n square, this will be 2k plus 1 whole square plus 2j plus 1 whole square, right? So this is going to give me 4k square plus 1 plus 4k plus 4j square plus 1 plus 4j. So this is going to be 4k square plus 4k plus 4j square plus 4j plus 2. Now here is what is interesting. If I go ahead and I take 4 common, then I realize that I will be left up with a plus 2, not plus 4. So anything divisible by 4 is getting added with 2. Try to understand. 4k plus 4j square plus 4j plus 2. So if I take 4 common, let this term be some term. Maybe this gives me a. So it will be 4a plus 2. So anything This entire term will be a multiple of 4, but I'm adding 2 to it, not 4. So it cannot be divisible by 4. It's like 48 is divisible by 4, but I'm adding 2 to it. 50 is not divisible. It's like 16 is divisible by 4. I'm adding 2 to it. 18 is not divisible. So therefore, we can go ahead and say that it will not be divisible by 4. And that would be the answer to this question. Okay, thank you.